All right, guys, here is the map scale exercise. And I'm assuming you guys read through it, but let me just point out a couple vocab words that you're going to want to remember. Scale, okay? And it is the relationship between the distance shown on a map and the actual distance that was represented on the Earth. So you have a couple different types of scales. You have that graphic scale, which is a picture, right? That's this one down here. Then you also have this fractional scale. We talked about this in class, also known as the representative fraction. And it's basically a ratio of what's on the map as to how much it measures in the real world, okay? Now you can write these scales in a verbal manner. So basically you're just writing the words out whenever you read the scale. One of the questions later will ask you for that. I think that you guys figured that out okay. So after you read through all this, and it looked like a lot of you guys got this down really well. So I'm not going to go through that. We'll just go ahead to getting to the problems. But something that I want you to think about is that large versus small scale maps and what that means. Okay. Large scale maps show small area in great detail, while small maps show large areas but in less detail. Okay. It's an important thing to remember whenever you're looking at a map. If it has a small scale, you might be missing some details. Okay, so one thing that I wrote on several papers was to use units, and that helps me check what you're doing, but also it enables you to look back and figure out what you did, where you got numbers, and if you need to, correct something. So here we have a map with a scale of 1 to 24,000. That would be a fractional scale. A measured distance of 1 inch on that map is an actual distance of something in feet. Okay, so if we measured on the map in 1 inch, this means that in the real world, it's 24,000 inches. So let's write that down. Okay, 1, and then this 2 dash is a way of saying inches. And what the direction said, you would multiply that by the actual number of the scale, which is this. So times 24,000 equals 24,000 inches. Okay, that's where a place to put inches, your units. And then you need to convert it to feet. So to do that, 24,000, this time I'll write out inches. Okay, and we're going to divide by 12, which would be, our factor, because 1 foot equals 12 inches, right? Hopefully you remember how to convert those. And if you do that math, you would get 2,000 feet. Okay. In the next one, we have that scale there. And we've measured 4.5 inches, and we're going to miles this time. Okay. Luckily, they give us the conversion factor, so we don't have to do several steps of that conversion. So let's write it out. 4.5 inches times times the actual map scale number. Okay. And that is going to equal 281,250 inches. Then we need to convert that to miles, and the number that we'll multiply by is 63,360, and that will give us miles, which it's approximately 4.4 miles. Okay. And sometimes, these answers could be off by very little due to rounding differences. Somebody rounds to a smaller number, and that's okay. It's the process that counts. Okay, on this one, where's our map scale? Okay, we're measuring 4.5 inches again, and we're going to miles. So it's the same thing, just some different numbers. 4.5 inches times map scale number in the real world, which is going to give us 1,125,000 inches. Oops, I made an error. I just caught it. Hopefully somebody saw it. This. We do not multiply there, we divide. Okay? Hopefully you caught that. So again, here we will divide by 6,360, and that's going to give us 17.8. So why do we divide and not multiply? Let's just do a little review here. If we are given inches, okay, let's look at this one. Okay, so we have that many inches, and the way I taught you is you're going to multiply by the conversion factor, right? That magic box. And the magic box, since we're going from inches to miles, is 63,360 inches equals 1 mile, right? And since this would be considered on top, we'd want to put inches down here, right? So 63,360, put our units, and 1 mile. What's on the top and what's on the bottom will cancel. Doop, boop. This times 1 is the same number divided by this. So here we just kind of skipped the multiplied by 1 and did the division. Okay, that's why that is. Little review for you. Okay. Now, this next one, I button hooked you here on purpose. It says, oh, nope, that's number 5. We got one more to do here. Let's see, number 4. Let's take a look. We'll go back to black. There's our scale. Here's our measured distance. That's what we start with. We're in centimeters, going to kilometers. 7.5 centimeters, okay, times map scale equals 375,000. What's our units? cm. Okay. Now, you can either do this mathematically, you divide by 100,000, or you can do our little cheating trick where you write down the prefixes, killing happy dolphins, meters, does cause mayhem, right? Now, I put these in lowercase letters because, like I mentioned before, I'm a visual learner. And these are the bigger units than meters. These are the smaller units than meters. That's just how I remember it, okay? You don't actually write this part in kilometers. You don't use a capital K, but it's just kind of a visual thing for me. And we are at centimeters, right? Here's our decimal point. We want to go here. So 1, 2, 3, 4, 5 in this direction. So we go down here. 1, 2, 3, 4, 5. Boom. So that is going to give us 3.75 kilometers. 3.75. Okay? So those are done. Now this one. Notice this is the one that we use the map for, which I gave you. Ta-da. But it also says, using the appropriate graphic scale found inside the front cover of the lab manual. Uh-oh. You didn't buy a lab manual, so you don't have that. But let's keep reading. Determine the distance from this location to this location. Okay? Well, we can still figure it out, even though we don't have the graphic scale. We know this, don't we? So if we measure, I'm going to use millimeters because they're nice and small. I don't have to worry about being in between. Here's our millimeter. This would be 1 centimeter. And each one of those dashes would be a millimeter. Instead of inches, which are bigger, and then you got to do a fractions metric system for me. So we need to look for patrol cabin and rest house. Rest house is on the summit, the highest point of the mountain there. Okay, so here's the patrol cabin. Here's the rest house. And I can measure here using my ruler that we're going to get approximately 55 millimeters. Okay. So I didn't have you do this one, so I'm going to put my work down here for this question. So I'm going to run out of room. So we measure 50. Let me do a different color here. Come on. Oh, you're fighting me. Pen malfunction. There we go. 55 millimeters. That's what we measured on the map. So, map. And because of the scale, this fractional scale, we would take 55 millimeters, multiply by this number, and we would get a very large number of millimeters, okay, in the real world. So 55 millimeters on the map is this in the real world. Now, let's do our little cheating trick. Let's go back up here. This time we're at millimeters, right? But we're still going to kilometers. 1, 2, 3, 4, 5, and 6. All right. Come back down here. 1, 2, 3, 4, 5, and 6, which then gives us about 13.75 kilometers. Look at that. We answered this one, 13.75. But also wants it in statute miles, which is referring to land miles, the one that you're used to. There's also a nautical mile, which is a different number. So whenever you see statute, just think the normal miles that you know. So we need to convert this to miles. How are you going to remember to do that? Well, I cheated, kind of. And I went to this. And we're going from metric, or is an international system, to English, or imperial system. We have kilometers, and we want to get to miles. There's our multiplication factor. Okay? What does this mean if we do it Ammo's way with the magic box? Well, it means that 1 kilometer equals 0.621 miles. Okay? Which means we would multiply this by 0.621 miles. 1 kilometer goes down here. This cancels, so I know I'm left with miles, which is what I want. And what does that give us? About 8.5 miles. Okay? I'll move this. And that is 8.5. Boom. Let's flip it over. Okay. So, what does this say? If a measured distance of 10 inches on the map. So let's write down what we're given here. Okay, so we can get rid of excess words and just focus on what we got. Map, we measured 10 inches. Represents an actual distance of 5 miles. That's in the real world. Okay, so I'll write it as actual, actually what it is, 5 miles. And in this case, it's asking what is the fractional scale. Okay, so I like to write down what the question is to make sure that I give what it's actually asking. All right, so what are we going to do here? Well, first, we got to do what we did here in reverse. We got to convert these to the same units. Now, since we're going from actual to the map, it'd be hard to measure a very tiny fraction of a mile. So we don't want to convert this to miles. We want to do both in inches. So we need to convert this to inches. Okay? So I'm going to write this one out the long way, the Ammo style. If we're doing miles, I don't know miles to inches off the top of my head, but I do know feet, and I can go from feet to inches, right? And we know that 1 mile equals 5,280 feet. And we know that 1 foot equals 12 inches. Okay, now we can make our conversion. So we have 5 miles. Do it this way. 5 miles multiplied by our first factor. We'll go back to red. Miles on top, so we'll put miles on the bottom. 5,280 feet. Miles cancels. Now we have feet. We got to go from 1 foot to 12 inches. And we do this times this times this. What do we get? Okay. Well, that's not our final answer. We're still trying to get to the scale. And right now our scale is 10 inches on the map is this in the real world. We need to get the map number down to 1 for that fractional scale. How are we going to do that? Well, if we make this a fraction, 10 inches over 316,800 inches, we can cancel out 10 for both, right? Or divide by 10 both. And that would give us 1 over that. No units because it's a fractional scale. So one time you have a number without. And the way that they write it on the map would be with that symbol, 31680. There's our answer. Okay? All right. Now, this question and this question is relating to this graphic scale. Okay? So first it says, why isn't 0 at the far left of the scales? Like, why doesn't it start at 0 here and go this way? It's a good question. Well, if you take a look to see what the difference is between this first mile and this first mile, notice this is all solid. While over here, it's divided up, isn't it, in equal units. What this allows you to do is measure fractions of a mile. Okay, so it's easier to read fractions of miles or other units. Okay, so that's why they do that. You can see this one's divided up the same way. Each one of these, you know, the light one, then the dark, light, dark, is 100, 200, 300. Oh, nope, that's not right, is it? Yeah, 500 is right there. So right here would be 100, 200, 300, 405. Okay? So that's that one. Now, this question. We're talking about scales here. And what happens if we change the size of the map? So if a map with graphic scales, these ones specifically, is enlarged, like you kind of photocopy it, but then you enlarge your copy, so the scales get enlarged the same amount, right? That's a scenario. Will the fractional scale of the map change? Why or why not? Okay. So what I did is I just found a picture and overlaid. This is a topographical map. Image off of Google, but then I overlaid this graphic scale, okay? Just arbitrarily to teach this concept. So here, from here to here on this map is, each one of those is a kilometer. So that's 1 kilometer, 2 kilometers. So this body of water is 2 kilometers wide in the real world. And if I would measure this, okay, I'll do it then. From here to here, that's 1 centimeter. Okay. So if I'd write this in fractional scale, it would be 1. Now, this is in kilometers, so it wouldn't be to 2, right? We would have to convert it to centimeters, which I'll just quickly tell you, it would be that. So that's our fractional scale for this map. Now, I took this picture, same picture, and just shrunk it. Okay? And if you look, this graphic scale is still the same, it's measuring the same distance on the map because it got smaller at the same percentage as the map. So no matter what happens, you make this bigger or smaller, the graphic scale, as long as it's getting enlarged or made smaller the same as the map, these are still usable. But down here, remember, that lake is 2 centimeters long or wide, which would change the 2 kilometers. Here, 2 centimeters is actually 4 kilometers in the real world. Okay, so using that, we would then be able to understand that, will the fractional scale of the map change if we change the size? Well, sure will, right? Because the size of the map relative to Earth has changed. Okay? To demonstrate that one more time, on this version of the map, 2 centimeters measured on the map, okay, anywhere, 2 centimeters, in the real world is 2 kilometers on this map. If I measure the same thing here, it changes to 4. Okay, so this map is half the size of this one. This question asks, will the graphic scales shown above, still be usable? And why? Well, we could still use the graphic scale as long as it changed size the same. Okay, so yes, we enlarged, well, we'll say they, as in the scale and the map, they were enlarged the same amount as the map. Okay? Now, if we would change the size of the map but did not change that graphic scale the same, like photocopied them together, then they wouldn't work. But in this scenario, yes. Okay? All right, so that is map scale exercise. On to the